Have you ever stood at the edge of the ocean, mesmerized by the rhythmic rise and fall of the tides? It's a natural wonder that has captivated humanity for centuries. But have you ever stopped to wonder, what invisible force orchestrates this watery dance? The answer lies high above us, in the celestial embrace of the moon. While it may seem counterintuitive, this celestial neighbor, bathed in reflected sunlight, plays a pivotal role in the ebb and flow of our planet's oceans. Join me, fellow science enthusiasts, as we delve into the fascinating world of tides and uncover the secrets behind the moon's influence on Earth's watery embrace. Get ready to explore the cosmic connection between the moon and our oceans, as we unravel the science behind this natural wonder. To grasp the moon's influence on tides, we must first understand the invisible force that governs the cosmos: gravity. Gravity is like an invisible string that pulls objects towards each other. The bigger an object, the stronger its gravitational pull. Think of it like this. Imagine you're holding a large beach ball, and your friend is holding a smaller tennis ball. If you both pull on a marble placed in the middle, the marble will be pulled more strongly towards the bigger beach ball, right? Similarly, the Earth, with its massive size, exerts a strong gravitational pull. Now, even though the moon is much smaller than the Earth, it's still close enough to exert its own gravitational pull on our planet, and this pull is what creates the tides. Here's how it works. The moon's gravity tugs on the Earth and its oceans. This pull is strongest on the side of Earth that's facing the moon. This gravitational tug creates a bulge of water on that side, which we call high tide. But here's the interesting part. A high tide also occurs on the opposite side of the Earth, furthest from the moon. This is because the moon's gravity is pulling the Earth towards it more strongly than the water on that far side, creating another bulge. So, as the Earth rotates, different locations on Earth pass through these tidal bulges, experiencing high tides when they're within a bulge and low tides when they're not. It's like the ocean is breathing in and out, guided by the moon's gentle pull. Now, let's picture Earth doing a slow, graceful pirouette in the vastness of space. As our planet spins on its axis, it takes about 24 hours to complete one full rotation. This rotation plays a crucial role in the timing of our tides. Imagine Earth as a spinning top, and the tidal bulges created by the moon as two stationary hands. As Earth rotates, different points on its surface pass under these hands, experiencing high tide when they do. Because we have two tidal bulges, most coastal locations experience two high tides and two low tides approximately every 24 hours. It's a cosmic dance between Earth's rotation and the moon's gravitational pull, creating the rhythmic ebb and flow of our oceans. Section 5: Spring tides and neap tides. The sun joins the dance. While the moon is the primary choreographer of our tides, the sun, our very own star, also plays a part in this celestial dance. The moon's gravitational pull is the dominant force, but the sun's influence is significant and cannot be ignored. The sun's gravity is much stronger than the moon's, but it's also much farther away. This distance means that the sun's gravitational effect on Earth's tides is less direct, yet still impactful. However, during certain alignments of the sun, Earth, and moon, the sun's gravity can either amplify or diminish the moon's effects on tides. These alignments create variations in the tidal patterns we observe on Earth. During a full moon and a new moon, the sun, Earth, and moon are roughly aligned. This alignment causes the gravitational forces of the sun and moon to combine, leading to noticeable changes in the tides. During these times, the sun's gravity combines with the moon's, pulling in the same direction. This combined pull results in higher than usual tides, known as spring tides. This creates extra high tides called spring tides. These tides are particularly strong, and can lead to higher water levels along coastlines. Conversely, during the first and third quarter moons, the sun and moon are at right angles to each other, relative to Earth. This right angle alignment changes the way their gravitational forces interact. In this configuration, the sun's gravity partially counteracts the moon's gravity, resulting in less extreme tides called neap tides. These neap tides are characterized by lower high tides and higher low tides, creating a more moderate tidal range. Section 6: The moon's elliptical path, a cosmic dance floor. You might picture the moon's orbit around Earth as a perfect circle, but in reality, it's slightly elliptical, meaning it's a bit oval-shaped. This elliptical orbit means the distance between Earth and the Moon isn't constant. When the Moon is closest to Earth in its orbit, a point called perigee, its gravitational pull is stronger. This stronger pull results in higher high tides and lower low tides. Conversely, when the Moon is farthest from Earth, known as apogee, its pull is weaker, leading to less extreme tides. So, the Moon's dance around Earth isn't a perfectly uniform waltz, it's more like a cosmic tango, with moments of closer embrace and greater influence on our oceans. Section 7. Earth's elliptical orbit, a solar waltz. Just as the Moon's orbit isn't a perfect circle, neither is Earth's path around the Sun. Our planet also follows a slightly elliptical orbit, meaning our distance from the Sun varies throughout the year. When Earth is closest to the Sun, a point known as perihelion, the Sun's gravitational pull is stronger. This stronger pull can slightly enhance the tides, making them a bit higher or lower than usual. Conversely, when Earth is farthest from the Sun, at a point called aphelion, the Sun's influence on tides is slightly weaker. Thus, our planet's journey around the Sun adds another layer of complexity to the cosmic dance of tides, influencing their strength and timing throughout the year. Section 8. Tidal myths debunked. Setting the record straight. Now that we've explored the science behind tides, let's address some common misconceptions. There are many myths and misunderstandings about how tides work, and it's important to clear them up. One common myth is that high tide only occurs when the Moon is directly overhead. This is a simplification and doesn't capture the full picture of tidal dynamics. While the Moon's position does influence tides, it's not the only factor at play. The Sun also has a significant effect, and the gravitational pull from both celestial bodies creates complex tidal patterns. Tides are actually very long waves that move across the ocean. These waves are influenced by the gravitational forces of the Moon and the Sun, but also by the Earth's rotation and the shape of the ocean basins. The timing and height of tides at a specific location are influenced by factors like the shape of the coastline, the depth of the water, and the Earth's rotation. Local geography can significantly alter tidal patterns, making them unique to each location. So even if the Moon isn't directly overhead, a coastal location can still experience high tide as a tidal bulge travels across the ocean. These bulges are the result of the combined gravitational forces and the inertia of the water. It's like a wave in a bathtub. The water sloshes back and forth, even if you're not pushing it directly. This analogy helps to visualize how tidal forces work on a much larger scale in our oceans, creating the rhythmic rise and fall of sea levels we observe as tides. Section 9. Tides, a vital rhythm of our planet. As we've discovered, tides are a fascinating and complex phenomenon driven by the cosmic dance between the Earth, the Moon, and the Sun. This intricate relationship creates the rhythmic rise and fall of ocean waters that we observe along coastlines around the world. The gravitational pull of the Moon, and to a lesser extent the Sun, orchestrates this mesmerizing movement. But tides are more than just a scientific curiosity. They play a vital role in the balance of our planet. The gravitational forces at play ensure that our oceans remain in a state of dynamic equilibrium, which is crucial for maintaining the stability of Earth's environment. Without tides, the distribution of heat and nutrients in the ocean would be vastly different, potentially altering the climate and ecosystems as we know them. Tides help to circulate ocean water, transporting nutrients and oxygen that are essential for marine life. This constant movement ensures that marine ecosystems remain healthy and vibrant. The upwelling of nutrient-rich waters supports the growth of phytoplankton, which forms the base of the marine food web, sustaining a diverse array of sea creatures. They influence coastal ecosystems, shaping the habitats of countless plant and animal species. The intertidal zones, where the ocean meets the land, are particularly dynamic environments. These areas are teeming with life, from tiny crabs and mollusks to larger predators like birds and fish, all of which depend on the regular ebb and flow of the tides for their survival. And they've played a crucial role in human history, shaping our relationship with the sea for navigation, fishing, and coastal living. Ancient civilizations relied on the predictability of tides for their maritime activities. Fishermen have long understood the importance of tides in bringing fish closer to shore, while sailors use tidal patterns to navigate treacherous waters safely. So, the next time you stand at the edge of the ocean, mesmerized by the rhythmic ebb and flow of the tides, remember the cosmic dance that creates this natural wonder. It's a moment to reflect on the incredible forces at work, far beyond our immediate perception, that shape the world we live in. The tides are a reminder of the delicate balance that sustains life on Earth. It's a testament to the interconnectedness of our universe and the profound influence that celestial bodies have on our planet. The gravitational interactions between the Earth, Moon, and Sun are a beautiful example of how interconnected systems can create harmony and balance. This cosmic interplay is a source of wonder and inspiration, reminding us of our place in the vast universe. Keep exploring, keep questioning, and stay curious. The more we learn about the natural world and the forces that shape it, the more we can appreciate the beauty and complexity of our planet. Curiosity drives discovery, and discovery leads to a deeper understanding of the world around us.